Hello, in this video we will be discussing the node voltage equations, how to create them, which is just another method of how solving a circuit. And node voltage is just an application of Kirchhoff's current law. So it seems a little backwards, but you'll see why in a minute. But we talk about node voltage being associated with the current law and mesh currents then being associated with the voltage law. But let's do an example. We can clear that up. So let's start with, we've got our circuit. 12 volts. We'll have resistor here, resistor here. We'll come up from the top, put one in parallel. Another here. And lastly one there. 2, 4, 6, 8, and 10 ohm resistors. Now to start with node voltage, first you define your ground. You can put it anywhere you want. For simplicity, we usually put it at the bottom of the circuit. But you could put it over here. You could put it over here. Although that wouldn't make a whole lot of sense since you've got a voltage source there. But if you put it, say, over on this side here, you're going to end up with a supernode. And supernodes are a little more difficult to solve for, but we'll go through that in this lecture. So for simplicity, let's start with it at the bottom. So we know already nodes are just our wires, V2, but V1 here, V2 here, and V3 here. You can check this yourself. But what I want to do is set up a system of equations that solve for each of these variables. And the way I want to see these on your tests is something like this. We've got N1 colon or parenthesis, something like that, and then your equation. So I'm going to use colons. And N1, my first node equation, I'm going to go with the easiest I can see, which is V1. And V1, of course, is just 12 volts, right? It's connected right there to that voltage source. N2, now this is where we start using Kirchhoff's current law. I'm going to sum all the currents as if they were flowing away from that point. Now, obviously I'm going to be wrong on one of these, but the math is going to hold up as long as I'm consistent. So in this case, I'll have V2 minus V1 over 8. Now, here I was talking about currents, yet I put it in terms of voltage and resistance. Well, if you remember Ohm's law, right? V over R equals I, and that's all I've done. I've just replaced that current for each of these branch with this equation. And we can go through the other two, like so. V2 minus V3 over 6. And lastly, V2 over 2. Now, if you want to get technical, it'd be V2 minus 0. In this case, it's just ground, we can ignore that 0. Always remember, has to equal 0. Sum of those has to equal 0. That's just our Kirchhoff current law. How about for node 3? Well, we have current here, we have a current here, we have a current there. Now, even though these two currents here look like they're flowing in opposite directions, as long as I'm consistent about the way I set up these equations, the math will hold. So what I can say is V3 minus V2 over 6 is that current, even though it contradicts what I have right there. One of those is going to be backwards. So either V2 is going to be bigger than V3 or vice versa, and then one of these will be negative. That's just fine. Just be consistent. Then I go to my next current, V3 minus V1, all the way back over our circuit, over that 10 ohm resistor at the top. And then last, V3 over 4. And of course, do not forget that it equals 0. And that is how we do node voltage. We've taken each of these nodes, we put it in terms of voltage and resistance, and use Kirchhoff's current law then to make our system work. So if you want, and I really encourage you to try this, separate these out into their respective variables, put them in a matrix form, and then solve it at MATLAB. It's good practice for MATLAB, and it's good practice for you. On a test, all I'm ever going to ask is just what these node equations are. Solving matrix math is tedious, it's hard to do, not everyone has great calculators for it, so all I want is the node voltage equations. And when we get to them, the mesh current equations. This is the electrical engineering part. The solving matrix math, that's just algebra. Still, do it in MATLAB, it's good practice. Alright, so how about supernodes? And what the heck is a supernode? Well, it looks something like this. If we have our circuit from before with one minor adjustment, I'm going to replace a series resistor with a source. This is a supernode, and what that means is that I don't know what the current is here, because it's going to be whatever is required to keep it at, let's say, 5 volts. So I don't know specifically what that current is, but we can solve for it pretty easily. So draw up our old nodes. Our first node equation, N1, is real easy. Okay. How about V2? Well, we can do V2 as well. All we have to do is what we did last time. V2 minus V1 over, we'll set up the same as we had before. We'll say 2, 4, 6, and 8. So over 8 plus V2 over 2 plus V2 minus V3 over 6 equals 0. Yeah, not so bad at all. But V3 is where we get into trouble, because we can't say that the current there is going to be equal to this, right? Because we replaced that 10 ohm resistor. But if we think about this critically, well, at V1, we've got a 10 volt source. If we follow that branch, we go up another 5 volts. Okay. So V3 then, it's just V1 plus 5. Since we know V1 here, we can sub that in, and we've already got 2 of them solved. So that's pretty easy. Let's try a little harder one. We'll go with our old standby circuit here. So this is R1, R2. Now here, instead of a resistor, now we've got another source. That's going to give us some problems, right, for V3 and for V2. So V3 twice, get rid of that one. V2 and V1. Okay, so V1, do it now because it's easy and I like having things up here. So V1 equals 10 volts. V2 now. Oh, that's tough. How can we get V2? Well, if we remember from Kirchhoff's current law, the current on this branch has to equal those currents, right? Because we have this node here. So the currents flowing in have to equal the current flowing out. Or, as we said, all these currents have to sum to 0. Alright, so let's try that. If, say, this is our 3, and this is our 4, this can be I4, and this can be I3. We'll call this one just IS, current for the source. So let's put down our law equation. IS equals I3 plus I4. Okay. Now let's try this node voltage equation. We'll start off real simple. I'm going to start off with just the currents, without any substitutions. So first I have I1, current over R1, plus I2, current down that resistor R2, plus IS, right? These have to equal 0. But now I can replace IS with our law equation. So I1 plus I2 plus I3 plus I4 has to equal 0. And from here, now I can translate this into node voltage. So I1 is just V2 minus V1 over R1. I2 is just going to be V2 over R2. I3 then is V3 over R3. And I4, V3 minus V1 all over 10 equals 0. Okay, so now we've got an equation in terms of both V2, V1, and V3. So how about node 3? Node 3 is just going to be easy again. We think about this critically. V3 is just V2 plus whatever the source is. We'll say it's 5 volts. And there you have V3. And we can sub that in, do our matrix math, and voila. That is how you solve for a supernode.